what a program is. Let's spend a few seconds talking to your partner.
Program is making the diagram. We want to achieve the goal. It's the step system inside the computer.
Okay.
Program is to communicate with foreign country people and everybody.
I think the program is the computer languages.
Okay, computer languages.
The computer program is the instruction to the computer.
Yeah, so a program is a set of instructions for a computer. So we're going to write our first program. So all of you have a maze and some arrows. So what we will do is we want to reach the goal. So at the bottom, we want to reach the bottom from the top, but you only have 2 instructions that you are allowed to use. You can only move forward 1 space, and you can only turn clockwise 90 degrees. So only these 2 instructions. So my question is, how many steps do you think it will take for your arrow to go to the end? So you can only go 1 step or turn. Turn 90 degrees in place. So please talk to your partner. Feel free to use this. How many steps do you think it will take to get to the end?
Question. Where's the initial location of the arrow? It's the outside of the outside. Okay.
Right outside. Yeah. Solution. Move forward 1 space. Move forward 1 space. Turn clockwise 90 degrees. Oh, that's it should be counterclockwise. Yes, clockwise. Move forward 1 space. Turn clockwise 90 degrees. Turn clockwise 90 degrees. Turn clockwise 90 degrees. Move forward. So it's getting really repetitive, right? So let's abbreviate. F is forward and T is turn. Okay, let's abbreviate. Also, I'm very sorry if I told you to turn the wrong way. So instead of writing these out, we have 1 symbol to signify move forward 1 space, 1 symbol for turn clockwise. Okay? So now it's your turn. On your whiteboard, please write down, finish the rest of this. What are the instructions? 38.
Yeah.
39.
E.
40.
Yeah.
Whoa. So one of the first things that we teach in our coding school is you can't rely on solutions when you are a software engineer, right? You will know your code is correct if it gives you the correct answer. The second thing, what happens, my second question, what happens if I change 1 instruction? Let's say I change number 25 to an F. What happens? We cannot get to the goal. Yeah. 1 incorrect instruction means that we fail. Our program does not work. Only 1. So if you miss something, if you write something wrong, it doesn't work. And that's what's really annoying about coding. We have to be very specific about our instructions and very exact. Any difference and things stop working. Okay? So every single instruction and symbol in code can make or break your program. And that is very frustrating for people who are not programmers. If you take a test in school and you get 9 out of 10 problems correct, that's good. That's not bad, right? If you get 99 out of 100 correct, that's good. In programming, your code does not work. 99 is not good enough. Your program won't work. So that's very tough to deal with. Okay? So coding is writing instructions for a computer. Programming, the act of writing these instructions for a computer. Okay? And we use programming languages to write these instructions. These are languages that we are using. So here are some programming languages. We like to divide languages into 3 different types. The first one is called machine language. It is at the lowest level. We call it machine language because it talks to the machine, the chips, right? And it looks like zeros and ones because for machines, we just had an on and an off. You get electricity, you don't get electricity. So 0 and 1. And then we thought, that's very difficult. Let's try to make it easier. So just like how in the beginning we had a long instruction and we gave it an abbreviation, you can think about that as assembly language. We made it easier to understand and easier to write. The zeros and ones, each sequence was given another command. Okay. And now we have high-level language. So almost all programmers and engineers use high-level languages. And these include many languages that you probably have heard people talking about. Python, Java, PHP, Ruby, JavaScript, Perl, COBOL, Swift, C++, C#, and all of these. These are all under high-level language. So this is where we have taken the 0 and 1s and we have made it look like a language similar to English, something that we can understand as people. So why do we have so many other programming languages? Well, each language has different ideas for how to communicate. Just like how there are many different languages in the world, there are many different ideas for how we go from here to here. Many different ways of writing, of thinking. So this is why we have different programming languages. So one of the most influential people in programming is a woman named Grace Hopper. Has anyone heard of her? One person. Cool. She changed the world. Most of the things that, or almost all of the things that we do with computers, we can thank her. So what she did was she wrote a program, and a program is a set of instructions. Right? She wrote a program called a compiler. And what the compiler did was it translated human-friendly code into code for machines. Okay? So she found a way to be able to write instructions for a computer that looked like English. And this program she wrote would translate that to zeros and ones for the machine. Okay. And her compiler evolved into one of the first programming languages. It's called COBOL. It's still used today. The work that she did on compilers was revolutionary. This idea that the instructions we give to computers are languages and can be treated like a human language. So this was very, very revolutionary. So this is what machine code looks like. And today we are learning JavaScript. This is what JavaScript looks like. Much more understandable, right? We see some English that we recognize. Here it's all zeros and ones. Can you believe that this does the same thing as this? Does the same thing. Let me know if you don't think so, if there's something wrong. Well, so programming languages are not built for computers. We did not create programming languages for computers. We created them for us, for humans. It was created so that we could write instructions and then have a computer use it. So programming languages are built for humans and then changed, compiled, into machine-readable code. So there's many things that programmers have in common with writers. Finding ways to communicate to the machine and also to other people.